Hello class, today I'd like to teach you about proving triangles to be similar but not congruent. Congruent means they are identical, same size, same shape. All three sides are identical, all three angles are. Those are congruent. And we had 5 ways to prove that: side, 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 angle, side, angle, side, angle, 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 side, and an HL if it was a right triangle. Now, with similar, we're talking about the same shape, but different size. It could be small, big. For instance, I don't know if you're aware that like a baby grasshopper and an adult grasshopper, they look identical in every way except one's just small and one's big. Those are similar. Now, in geometry, we have 3 ways to prove that triangles are similar. And over here on the board, the 3 ways are side, side, side similarity, side, angle, side similarity, and angle, angle similarity. And notice the little curvy thing. That's the similarity symbol. It's different from the congruent because the congruent had an equal sign under it. Now, side, side, side doesn't mean all sides are the same length, but they are all in proportion to each other. So, for instance, over here, side 10 corresponds to side 5. And so that's in a ratio of 10 to 5. Side 6 goes with side 3. And side 4 goes with side 2. And they're all 2 to 1. So if they're all the same proportion, then we absolutely know that the 2 triangles are similar. Now, a second way is side, angle, side, where you've got 2 sides that are proportional and one angle from each triangle is congruent. So, for instance, this one right here. Since this little triangle and the bigger triangle share the same angle, that means those 2 angles are congruent for both triangles. And this side of the small one is 5 compared to 10 of the big one. This side is 4 of the small compared to 8 of the big one. So again, this is a 2 to 1 ratio. And so these 2 triangles, the big one and then the smaller one on top of it, are similar by side, angle, side. And then the third way is angle, angle similarity. And all that means is you've got 2 triangles and you've got 2 angles that you absolutely know are congruent to each other. So for instance, these 2 triangles, that double tick mark matches that double tick mark, that single tick mark matches that single tick mark. So we can say that these 2 are similar through angle, angle similarity. All right, let's look at the notes now. We're asked to prove if the 2 are similar, and if so, to write the similarity statement. Now, as I'm looking at these 2 triangles, I notice they both have a congruent angle, and they both have the same proportion in side. So we can safely say that through side, angle, side similarity, these 2 triangles are similar. Now, the similarity statement is a little bit tricky in that you've got to match everything. So it says here triangle JKL would match triangle. All right, I'm going to start with the single tick mark with the single tick mark. That would be triangle TRS. Now, in number 2, we've got 2 triangles. We don't have any angles indicated. So let's agree. In fact, I'm just going to write it over here. The 3 ways are side, 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 angle, side, and angle, angle similarity. Now, because there are no angles indicated that are congruent, it could not possibly be number 2, side, angle, side. It could not possibly be number 3, angle, angle similarity. So it's either side, 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 or they're not similar. So which side do you compare with which? Well, you take the biggest side of this one and compare it with the biggest side of this one. So we'll say 96 compared to 36, is that the same ratio as 88 compared to the middle-sized one, which is 33? And is that the same ratio as 64 is there compared to the smallest one there, 25? And so we don't know, and so we have to enter them into the calculator, change it back to a fraction, and you'll find out that this proportion is 8 to 3, that proportion is 8 to 3, looking good so far. However, this one does not reduce, 64 to 25. So these two are not similar. All right, examples 3 and 4 from your notes. Now, as I look at example 3, we've got a large triangle that's laid over on top of it is a smaller one. So since they share the same corner, we know that those two angles are congruent. So I don't have all three sides indicated, so it could not be side, side, side. It could be side, angle, side. And since I don't have two angles congruent, it's either side, angle, side similarity, or it's not similar. So let's see what we got here. From U to T is 84. And so we're going to say that big side 84 compared to the small side that goes with it, 35. Is that the same as the big side here, 96, compared to, oh, I want this one, but I know from here to here is 56, so 56 from 96, that means that must be 40. So again, we're saying, is this big side compared to that small side the same proportion as that big side compared to that small side? And if you do the work in the calculator, sure enough, you'll find that they both reduce to 12 over 5. So by side, angle, side similarity, these two triangles are similar. Now let's get the right similarity statement. It says triangle UTS. Well, that must be similar then to UDE. Okay, over to number 4. Now I can immediately see, obviously they've got this angle and that angle are congruent, and because they share a common vertex, that angle is congruent for both. So since we have two angles that are congruent, we can say yes, these two are similar by angle-angle similarity. And the common sense reason is, why would we know that these two unmarked angles have to be the same? Well, because they all add up to be 180. And if these two are the same for both, then that just leaves it, the other one has to be the same as well. Okay, so we're saying triangle SRQ would be similar to triangle SEF. And that's examples 3 and 4. Okay, examples 5 and 6. Well, in example 5, we have no angles that are tick marked, so it could not possibly be side, angle, side. It could not possibly be angle, angle. So it's either side, 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 or they're not similar. So let's take biggest to biggest. The biggest one down here is 45, and that would compare to the 9 there. The middle size one down here would be 40, and that would compare to the 8 up above. And the small side here, 35, would compare to the 7 over here. And sure enough, they all break down to the 5-to-1 ratio. So, by side, side, side similarity, these two triangles we absolutely know are similar. Now, these are the ones that are a little bit harder to get. It says side STU, all right, that's STU, that's this one with the big one and then the middle-sized one would be similar then to, all right, big one and middle size, so it'd be SLM. Those are, I find, a little bit harder to get at. Now, number 6, I can immediately see that these two are not similar. The only angles that are congruent are these two vertical angles. Just because these are tick marked, that doesn't mean anything unless we had a 3 tick mark one here and a 3 tick mark one there, or a 2 tick mark one there and a 2 tick mark one there. So these two are not similar. And that's numbers 5 and 6. All right, students, 7 and 8. Well, we can immediately see that those two angles are the same and they share that common vertex. So yes, by angle similarity, and triangle LMN, the big one, must be then similar to triangle LTS, the small one. Now, in number 8, this is one of the more challenging ones, but your clue are these parallel lines. So when you see parallel lines, you want to think of alternate exterior, alternate interior, same side interior, or corresponding. We have no side links indicated, so it could not be side, 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 could not be side, angle, side. So it's either angle, angle, or it's nothing. Well, clearly they share a vertex, so we got one angle for sure. Now, I'm going to go ahead and mark these, and I wonder if you remember, since those are parallel lines, this is a transversal, we can say that those are corresponding angles to each other. So those two are congruent. So yes, by angle similarity, those two triangles are. And we have triangle UTS would be similar to triangle ULK. And that's 7 and 8. All right, problems 9 and 10. Well, I hope at this point you can see, since no angles are indicated, it's side, 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 or it's nothing at all. So we're going to go big side to big side. Let's see, this would be 24 compares to the 12. The middle size 16 would compare to the 8. Oh, okay. And let's see, I've already lost my place. 12 then would go to the 6. And sure enough, these are all 2 to 1, 2 to 1, 2 to 1. So by side, side, side similarity, those two triangles are similar. And so we're going to say triangle EFG. Okay, now this is the big side and the little side, so that would be the same as triangle UVW. All right, number 10. Again, by now you should be used to noticing a common vertex, so that means the angles are identical, they're congruent. And since this piece is 4 and that's 16, this whole length, the big triangle, is 20. 5 and 8, that big thing is going to be 23. So we're going to ask ourselves, is this length 16 compared to that length 20? Is that the same proportion as this 23? Oops, no, I've got it upside down. 18 to 23. And you may be thinking, well, why didn't I use this one? I could have 17 to 24. And it turns out that these ratios are not the same. So this triangle is not similar, these two triangles. And that's 9 and 10. All right, now the remainder of these are already similar, and given that knowledge, we then need to find the missing sides. So we know that these two triangles are in proportion to each other. We're trying to find that length x. The trouble is, does this length x compare to the 22, or does it compare to the 18? Because frankly, I don't know if this number is bigger than 55 or smaller than 55. Well, here's where this comes in handy, the similarity statement. Let's take this segment, BC. that's going to be similar to BU. So BC, I'm just going to do this wavy little mark. BC's got to compare to BU. Okay, so I can say x over 18 would then correspond to 55 over 22. And when you do the math, and I have done it already, it turns out that x is equal to 45. Okay, number 12. We're looking for that little piece there. And so we could say that little piece x compared to the same side but the bigger side, 45. That compares then to 22 over the bigger side, 99. And if you do the cross multiplying, you'll get that, yes, that I had to pause for a second, that x is equal to 10. And that's 11 and 12. All right, examples 13 and 14. Well, we've already been told that they are similar, so we don't have to try to discern. So we're looking for that. But again, I can't tell, does this length compare to the 56 or the 88? So you look up here at the similarity statement. All right, segment CD, that's this one here, compares to UV. That's that one there. Okay, so I can say 88 compared to X must be 56 compared to 21. And you cross multiply and do the algebra, and that you get X is equal to 33. All right, number 14, a similar kind of deal. We know already from the instructions that they are similar. I just need to know, does this side go with the 56 or does that side go with the 72? So again, I'll look at the similarity statement. It says that FG, where is FG? That's this one here. That goes with AB. Okay, so I can say 72 to 27 is going to be the same as 56 to side X. Do the cross multiplication and the algebra, and you get X is 21. And so that's 13 and 14. All right, class, we're on the last two, 15 and 16. Again, we know they're similar because the instructions told us we're trying to solve for X. So let's see, how do we want to do this? Well, we can compare this length to that length as to this one to that one. So we can go negative 3 plus 12x compared to the shorter length, 27, would be the same proportion as 40 compared to 24. Now, you've got to use a distributive property. You're dealing with some fairly big numbers, but after you cross multiply and solve for x, you get that x is the number 4. And finally, over here in number 16, again, right at the moment, I don't know, does the 6x minus 6 side, does that correspond to the 20 or the 18? So I look up here, I see that segment TU, where is that? That's this one here, goes with JK. Where is JK? Okay, so I know that 27 then compares to 18, which means then that the 6x minus 6 compares to the other side, 20. And you cross multiply, and when you do the algebra, you get that x is equal to 6. And there you have it.